Hi students, uh, let us continue with a video on square wave generation. Uh, by this time you are very familiar with this circuit which is for generation of a square wave using operational amplifier, and we have a timing capacitor, timing resistors, and then R1 R2 are the feedback resistors, and we know that this is the output waveform and this is the voltage across the timing capacitor. This is plus Vsat, minus Vsat, and the capacitor voltage, timing capacitor voltage is swing between VTH and VTL. We know that the capacitor voltage is given by this equation. Capacitor voltage is given by V final minus V initial power minus T by RTCT. So let us, uh, we already know some equations how to find T on T off. So let us try to realize one more expression, generalized expression for T on T off, and try to get how do we easily find the theoretical value of T on T off. So now let us continue with for simplification. So what I'll do is I'll just write this is Vc of t. I'll take this Vf onto left hand side. It will become minus of Vf. This is equal to minus Vf minus V initial into e power minus t by rt ct. So there is a negative sign here. So let me just multiply on all sides by on either side by negative sign. So then this will become Vf minus Vc of t. So this will become plus. So this will be Vf minus V initial e power minus t by rt ct. So now this will be the expression. So then I can just rearrange this. So I can write Vf minus Vi e to the power of minus t by rt ct is equal to Vf minus Vc of t. So finally I can write e power minus t by RTCT as equal to just simple cross multiplication Vf minus Vc of t divided by Vf minus V initial. So I can eliminate this negative sign and then rewrite this as I can write here e power t by RTCT will be equal to, because this will be get reversed, so it will be Vf minus Vi V final minus V initial divided by V final minus Vc at t. So now I can just do natural lag on either side, then this will become t t by rt ct is equal to ln of V final minus V initial by V final minus Vc of t. So this is my expression. So finally I can write t is equal to RT Ct into ln of V final minus V initial divided by V final minus Vc of t. So now my equation simplifies to this equation where I can write the expression for t. Expression for t is now equal to RT Ct into ln of V final minus V initial by V final minus Vc of t. This will be my expression. Now let us try to get an expression for t on. So let us make this t is equal to t on. So then this is t on is equal to, this is RT Ct, this ln remains the same. So now when you are trying to find what is this t on, Vf will become plus Vsat. So this is now plus Vsat. So this is now plus Vsat minus of what is V initial. We know that for finding T on, the V initial is V initial. This is my V initial, which is nothing but VTL. So minus of VTL divided by, this is plus Vsat minus Vtl. What is V final? It's again plus Vsat minus what is Vc of t at t is equal to T on. So this is Vc of t at t is equal to T on. So now Vc of t will become Vth. So now the expression for T on is equal to RT Ct ln of plus Vsat minus of VTL divided by plus Vsat minus of Vth. So this is my expression. This is my expression for T on. So while performing the experiment, I will be knowing what is RT, I will be knowing what is CT, I will be measuring what is plus Vsat, I will be knowing what is VTL from that capacitor voltage. I again know what is plus Vsat, I will be knowing what is the capacitor voltage, maximum voltage. So if you know all these parameters, then you can easily find out what is T on, which we would have measured using the AD kit. You can compare that with this value. Similarly, here to have the expression for T off. So what is the expression for T off now? It is same expression. So I will write that RT CT ln of. So for T off, this is my T off. This is T off. So for T off time, what is the final voltage? If the capacitor is allowed to discharge till infinitely, it will become minus Vsat. So this Vf is minus Vsat. So I will write it as minus Vsat. So this is what is V final is minus Vsat. What is V initial? It is minus of, what is V initial? V initial for off time is Vth. So I will write V initial as Vth divided by what is Vf? Vf is minus Vsat. Vf is minus Vsat. What is Vct at t is equal to T off? So this is what is. So when t is equal to T off, what is the capacitor voltage? It is VTL. So here you can see in place of VCT, Vc of t at t is equal to T off, it is now VTL. So I am simply substituting what is final voltage as minus Vsat, V initial as Vth, V final is again minus Vsat, Vct at t is equal to T off is VTL. So now this is the expression for T off. This is the expression for T off. Now let us conduct an experiment and try to find out what is theoretical and practical values, which you can easily repeat for any values. So let me make the value of RT as maybe 22K. I'll make it 22K here. This is 1, 2. This is also 1, 2. So now it is 22K. My C of T is. Okay, now let me run this. So now let me write what are my RT, CT values and VTH, VTL. So the value of RT is 22 kilo ohm, C of T is CT is 0.1 microfarad. So let me measure what are my T on, T off, plus Vsat, minus Vsat, all those from my readings. Okay, let me run it again. So now this happens to be the duty cycle. So let me write the values that I'm getting from the screenshot. So duty cycle is 44.37% and the frequency is 217 Hertz. The positive with T on is 2.04 millisecond. T off is 2.56 millisecond. So C2 max is now plus Vsat. Plus Vsat is 4.12 volt. Minus Vsat is minus 2.76 volts. And what is VTH? VTH is your C1 max. It is 2.13 volt. and VTL, that is C1 minimum is minus 1.33 volt. So these are my readings. So these are my readings, what I got it from screenshot. Let me substitute all these values and try to find out what is my T on T off using the equations. So what I'll do now is, so this is now RT is 22 exponential 3 into 0.1 exponential minus 6 into ln of, open the parenthesis, again open, it is plus Vsat minus VTL. So it is 4.12 minus of VTL. So it is minus of minus will become plus 1.33, close the parenthesis, divide by, open the parenthesis, again plus Vsat is 4.12, minus of VTH is 2.31, 2.13. So now I have edited all these values. So it is now 22K, 0.1 microfarad, ln of Vsat minus of VTL, that will become 4.12 plus of 1.33, and divide by 4.12 minus of 2.13. So now if I do this, you can see now I'm having value as 2.216 millisecond. So this is my theoretical value what I measuring. Practically I got the value as 2.04 millisecond. 2.04 millisecond is my practical value. Okay, this is fine. So now let me find what is my T off time. For T off, it's again 22 exponential 3 into 0.1 exponential minus 6 into ln of, open the parenthesis, it is now minus Vsat. So minus Vsat is minus 2.76 minus of VTH is 2.13, close the parenthesis, divide by, open the parenthesis. How much is minus Vsat? Minus Vsat is actually minus 2.76, minus of minus, it is plus now, plus 1.33, close. If I run it, now you can see it is 2.7 millisecond. So practically how much I got? I got it as 2.56 millisecond. You can see this is my calculated value, this is my practical value, this is calculated practical. There's no huge difference between the theoretical and the practical values, they are almost matching. So let me find out what is the duty cycle here. So duty cycle is T on by T on plus T off. So as per my calculation, it is 2.216 divided by 2.216 plus 2.7, which is 45%. 45.07% is my duty cycle, which I got it as 44.37 is my practical duty cycle. Let me find the frequency. So frequency is, okay, let me just do this. Let me take out this value. So this is T on plus T off inverse, which is now, you can see now it is 203 hertz. 203 hertz. Practically I got as 217 hertz, which is not too far away from your expected value. So this is your practical value. This is your practical value. And what is there in the bracket are the theoretical, this is my theoretical value, this is theoretical, so these are my practical values which I measure from the analog discovery. So this is how you can able to, of course this is a simpler expression compared to of course what we have given in the last video. Of course this is exactly, these equations are exactly derived from this only. So here I ask you to just make this, okay, VTH alpha equals plus Vsat minus of so and so, and you are supposed to do shift cal twice. So instead of that, we have actually simplified the equation, got these are the expression for T on and T off. Now we are directly substituting what is plus Vsat VTL, VTH, and RTCT and all those stuff. So both are perfectly fine. So this is a simplified expression for on time or the timings. So this is the starting point of your equation. So both are exactly the same. So now there is another possibility of getting the different duty cycles. So let me just show that, okay, what is other possibilities of getting duty cycle. Here you can see, instead of grounding this, let me just show you here. Instead of grounding this R2, what I'll do is I'll connect a V reference. I will connect a V reference. So the moment when I connect a V reference, the voltage at this point, V plus, which is either VTH or VTL, will be having another term due to this V reference, because you have V naught here and this V reference, which is going to contribute to the voltage at the non-inverting terminal. So this plus term is actually V, let me write it here, it is V reference multiplied by R1 divided by R1 plus R2. So the expression for VTH will be this plus V reference R1 by R1 plus R2. Again, this is still minus V sat R2 by R1 plus R2. It will going to have another term which is due to V reference, which is plus V reference into R1 by R1 plus R2. So this is the expression for your T on T off. So what we'll do now here is we'll conduct an experiment having same values of some values of RTCT. Let us change the value of V reference and see can we get different duty cycle. Maybe in the previous video we have seen, okay, how to get different duty cycle by having a circuit which is having a totally different circuit where you used to have something like this. Do you remember? So we actually provided two different paths for your capacitor to charge. During positive cycle it was charging like this, during negative cycle it was discharging like this. By having different values of RT on, RT off, you could able to get different duty cycle. So that's what we saw. We could able to get up from 16% to 90% also stuff. Now there is another way of varying the duty cycle, having same value of RT. Now you are actually introducing a reference voltage at this point. By changing the reference voltage, I can get different on time, off time. Again, how do we do that? This equation still holds good. So whatever the equation that you have for any circuit, this holds good. The moment when you have a reference voltage, the VTL expression changes, because now VTL VTH expression will change, but whatever voltage you get it from your AD kit, you can just put it there and then verify the duty cycle. So what I'll do now here is, let me go to this wavegen. Let me have a wavegen here, apply some voltage through W1. So now what I'm doing is, over here to this circuit, in this circuit I'm connecting a reference voltage. Now in this case I'm actually connecting W1 here. W1 is connected to R2. The moment I do it, just have a look at what happens. I will just adjust this to, let me just take this away, take this separately outside, and then make this also half of the screen. Now you just lively see how does the duty cycle change when I change the reference voltage. Now you can see, let me make this something like this. Now let me make it DC. Now let me just keep running this all the time. Just have a look at the duty cycle. Duty cycle is 44% because this is now 0. The moment when you make this equal to maybe just make it 500 millivolt, can you see the duty cycle has changed to 48%? So change this to 1 volt. Can you see the duty cycle has become 53%? And of course the VTH VTL will certainly change, whereas this plus Vsat minus Vsat will remain the same. What will change when you change this reference voltage is the on time will change, off time will change, the capacitor voltage will change, that is VTH and VT will change, VTL will change. So naturally when you are changing the reference voltage, so let me go back to your equation, try to show what all things will change. So now let me show what all things will change. So when I change V reference, VTH will change, VTL will change. So when VTH, VTL changes, naturally T on as well as T off will change. So when T on, T off changes, naturally duty cycle will change, frequency will change, everything will change. Everything will change. What is that remaining constant is plus Vsat minus Vsat will not change. So now by changing the reference voltage, I can get duty cycles close to 90% or even I can get up to 10%. So here, if I'm increasing, just have a look at the duty cycle. Can you see, is it actually increasing? It has become 62%. Now it has, can you see, now it has become 68%. Can you see, now it has become 70%. Can you see, now it has become 78%. Suppose if I make this equal to maybe 4.2 volt, it is okay. 4.2 is too much. Let me make this equal to around 4 volts. You can see you have a percentage. Okay, let me just stop this. Let me make single shot. Okay, let me, when I make single shot, let me just see a few more cycles. Let me see a few more cycles and then run here. Now, 1 second. Now let me stop this now. Can you see duty cycle is around 88%, which is close to 90. Now this way you can able to change the duty cycle without having two resistors. What you are changing is you are having a circuit with a reference voltage which is connected to the resistor R2. So this is the way how you can change the duty cycle without having two timing resistors. With a single timing resistor I can get any duty cycle now. So let me show you how do I get a lower duty cycle also. Just have a look at this. Let me put it in run mode. Let me just keep reducing the voltage. You can see now the duty cycle is keep on reducing. Now it is 32%. You can see 26%. Can you see now it has become 23%. Can you see it is 15%. Can you see it is okay? What I can do is, okay, this cannot be 2. It cannot be lesser than minus Vsat. Now you can see it's around 16%. So this way, how to verify the values? So in the same equation, of what I showed earlier, so this is your equation. Keep substituting the measured values of Vsat, plus Vsat, VTL, VTH, plus Vsat, minus Vsat, VTH, VTL, and then you can verify the values. The only thing is that the plus VTL plus VTH expressions will be having one extra term due to V reference, So that is this term. So that's how you can able to get duty cycles of different value even having only one resistor. So this is one way of getting any duty cycle using two resistors. Here you don't have a reference voltage. So you can have a single resistor but have a reference voltage, you can still get different duty cycles. So that's what is the square wave generation using op amp. Thank you. So of course you can consider this for different values of threshold voltage, V reference. Find again VTH, VTL, T on, T off. So these are the measurement, and you can verify what is on time, off time, duty cycle, and frequency using this simplified equation from the main equation of capacitor voltage. Hope okay you will enjoy the lab when we do it in the lab. Thank you.